Hi, my name is Noah Gift, and I'm the author of these two O'Reilly books, Python for DevOps and also Practical ML Ops. And I'm going to talk through, in this next lecture here, how to build a real-world Python project from scratch, build it out into a library, command line tool, then build out a container, set up continuous integration, continuous delivery, and deploy that programmatically inside of AWS using ECR and App Runner. So really this is like maybe your first week at a job deploying microservices. Go ahead and get started, sit down and get ready to work. So you can basically choose the right tool for the job that you're working on. So if I'm building out a software project, I typically don't use Jupyter Notebook. I'll start to build out the structure in my code. So what I'll do first here is go ahead and select code, and I'll go ahead and select Codespaces. And so here we go. We can say welcome to cloud editing, edit, debug, and run your repository without local cloning and setup. These kind of code spaces are really helpful because you're co-located directly with a cloud environment, and you can actually just develop right inside of a web browser. So I'm going to show other ones as well. I'm going to show an AWS code environment, but let's start off with this one, which is new code space. And what it'll do is it'll provision behind the scenes here like a full software development environment. I think really the future is, I think most people will be developing in these kinds of environments. And you can see here that it gives you a Visual Studio editor type environment. You can even run Jupyter Notebooks. So if I wanted to click on that notebook right here, look, I can do the same. I can run the same notebook inside of here as well. So it's a neat little environment, right? And if I do print hello world, I can just pick this environment. There we go, hello world. So pretty neat little environment here that you get. And if I want to change the color of this, I can go to color theme and go to Visual Studio, make it a little bit clearer to see, and make it a little bit bigger as well. So these environments I think are much more suited for building software. Even though you can go through here and run Jupyter Notebooks, they're a little more highly tuned to building out the structure for a project. So if you were going to start to build out a microservice, what are the things that you should do? I'd say the first step would be to build out a scaffold for your project. So let's actually sketch this out like that, just like this. And we would have the file here that or the code repo. We can call this GitHub. And inside of this, we would have a Makefile like this. And then next up, we would have a requirements file. And this is where I would put in the packages that are going to be installed. This is a common convention in Python. It's not required. It's just a convention many people use. And then I would have my source code inside of here, and then potentially a test code as well, and then also a Docker file. That would probably be the structure that most modern DevOps projects would follow. Makefile, requirements, source, test, Docker file, and potentially as well one last piece of code, which would be your build process or your infrastructure as code. So I could even say IAC, infrastructure as code, which could be also a build configuration file. So I think we can cover this as well today. But if I was building out a DevOps structure for a project, this would be a good structure. In fact, I'll just go ahead and download this as well, and then put this into the notes. So that's the structure, and then we can say, scaffold like this, and then I can download the new one I just created and put it there. Perfect. And we can check this in, commit changes. Perfect. So now we have the scaffold. So that's what we're going to build out next here. And I just need to go back to my environment, and I can even do a git pull like this, and it will pull in the updated README. So how would I create this structure? I would say the first step that I would build for the scaffolding, and let's just label these steps. So step 1 would be create a virtual environment, a Python virtual environment. And the reason for this is that Python, because it's a scripting language, does require you to use some kind of a tool like this, or else there's subtle issues that crop up. So I typically will develop with a Python virtual environment. There's 2 ways to do it. The one way to do it is you do this. You would say Python 3-m v env, and then put it into a virtual environment like that. Another way would be to do the virtual environment tool, where you could do something like this. So either one, I can just put an or. Now in my case here, I'm going to go ahead and use this approach, which is virtual environment tilde.venv. Let's go ahead and do that, and let's go ahead and paste this in, and we can see that it was able to create this virtual environment. When I'm working in a cloud-based development environment like this, because I'm going to be using it over and over again and opening up lots of shells, I'll actually source the virtual environment inside of my bash configuration file. So I can do this. I can say vim bash rc like that, and put this at the bottom and say, sourcing Python virtual environments like that. And then from here, I can just source this .venv bin activate. There we go. So then every time I open up a shell, this will be sourced. And to test it out, pretty easy, I just go through here and just make a new shell, and look, there we go. I've got the Python virtual environment set up here. And what it does is it puts everything inside of this directory, so that I don't have package conflicts, or the system Python that's installed sometimes can have issues as well. But in general, this is a pretty good approach here to set up. So that would be step 1. The second step would be to create those files that I talked about earlier. So the second step is create the empty files. And you can do this with an editor, but I like to just do it, like if I said file, I could say new file like this. But I find it to be quicker to just use the touch command. So I can say touch requirements.txt. So we need a requirements file. We also need a Docker file. So that's another thing I'll need. I'll also need a Makefile. And we need some kind of source code as well. And this is where we could decide potentially whether we want to create a library structure for our code. And probably is a good idea to create a library if you're going to be working on a project with maybe a bit of logic inside. And so we can make a library as well. So we can do that. We can say make dir mylib like that, or whatever you want to call your library. Once you create a directory, in order for Python to be able to import it, you'll need to create a init under. So we'll say touch mylib and do under init like that. We'll go ahead and create this repo. And here we go. So I've got this this library created right here. That's great. And then from here, the only other thing I would need to do is put the actual source file inside. And I guess I can call this thing the logic. So why don't we go ahead and do that? I'll just say touch my lib, and we'll say logic.py, right? So we've got a good structure here, set up inside, right? We have a library code, and I can see this. Here's the ._init.py, which tells Python that it can import this directory. We have some logic here. We have a Makefile, a requirements file. So let's start building this structure out. I would say the first thing I would build, actually, we should also have the microservice built out. And so we'll create a main file. So we'll create a file called main.py, and this will import that library code. So this is a good structure here that we've got set up. And I could even put the notes, say create empty files. We'll say, a Makefile. We'll need a requirements file, requirements.txt. We'll also need a main.py, which will run our microservice. We'll need a Docker file, and then we'll do a lib. So my lib, and we can even show that it's got the _init inside of it. There we go. We've got this set up now. Populate the Makefile. That would be step 3. Populate Makefile. And so Makefile, the reason it's a good idea in a software engineering project is so that you can put these steps inside that are really the life cycle of your project. So let's go ahead and do that. So step 1 would be install, like this. And this would be where I would go through and do my pip install. So we'll just put a note here and we'll come back to it. We'll say install commands. The next thing that we would build would be the lint steps. So in order to check that our code has proper syntax, and in fact, there's a couple different tools. You could do Flake 8, or you could use PyLint. They're both fine. Then you would do a test step, and we can go here and say test, and then we would go through and do a final step, which would be a deploy step, and we can go ahead and do that. We can just say deploy, right? So what's neat about this is that it allows us to clearly articulate all the different things that we need to do for our project. So in order to run this, pretty easy actually, we could also do all. And what all does is it's a convention where you could run every single command together. And so you could do install, lint, test, deploy. Now we may want to add one more step, which is potentially right here. I like to do this as well, is we could have a format the code. Now, this is really the idea with a Makefile, is that it actually can run each of these steps for us. So if I go through here and I say make install, look, it doesn't do anything yet. It just shows the command that would run. And I say make format as well, right? Or I say make all, watch, it'll run all of them. Right, so this is kind of a fun way to play around with the Makefile, is first build one that does nothing so that you understand the steps. Really, it's just a tool that keeps you organized when you're building out a software project. And you can put anything you want in a Makefile. And the reason why Makefiles are so useful is that they're used in really pervasively in building software projects. And so not a bad idea per se, inside of a project for Python or any language, in fact. So I'm going to go ahead and say get status now, and I'm going to look at all the files that I've changed. So I've changed the notebook, I've changed the README file, I've changed Docker file, Makefile, main file, created a library requirements.txt. Let's go ahead and check all these in. So I can, because I've included the git ignore, and this is the reason for a git ignore, because I have this inside of here, what's great is that I can actually just do a git add star. That's one of the advantages. So I don't have to worry about checking in bad logic. So I can just type this command again, git add star, like that. And then from here, if I type in git status, now they turn green. It says, yep, here's all the files that I'm going to push into my repository. Let's go ahead and push this in. We'll say git commit and say adding initial DevOps structure. There we go. And let's go ahead and push that change into the repo. Okay, we've got that going. And in fact, if I go back to my GitHub environment here, let's refresh this. We should see that there's the commit, right? So this is the advantage of the cloud-based development environment. Very fast, right? Instant feedback inside of here. So next, what we can do is I can actually start to fill out what these commands should be. And probably to start with, we need to put our software packages inside. And so what we'll do for this project is I'll build out initially what would be a good structure for the project. So we were using the Wikipedia tool. Let's go ahead and put that in there. We'll say Wikipedia. We were also going to test our code. So I like to use Pytest and also a coverage tool called Pytest Cov, which will give us how many lines of code are covered. Also, we could use a linting tool. So I'll go ahead and use PyLint. I can also install the formatting tool, which would be Python Black. And then I can also use a library called Python Fire, which makes it really easy to write command line tools in Python. You can just take a function and map it into a command line tool. We can go ahead and use that tool as well. And so now we've got really a pretty good structure for what we would need for our project to start with. And what I like to do is actually put this inside of a Makefile. So I have actually another project I can just grab a Makefile from. We'll go to Pytest here, and I can just look at some notes for another project and just take some notes out of this. So probably this is a good command here to put in. And the reason why I like this command, like this, pip install, and I guess we could leave this note here for now, but pip install -- upgrade pip. This is really common, and so because I have to type it a lot, I just don't want to type it. I'm just going to always upgrade the Python packaging tool to be the latest tool, and then go through and install everything that's inside of that requirements file. So let's go ahead and do that. I just now type in make install, just like that. We type in make install, it goes through and it installs all of our packages here. Great, we got all this stuff working here, which is nice. And what does that give us? Well, it is able to actually install everything that's inside of this requirements file. And one other thing we can do is pin the version numbers so that later, if in 2 years somebody checks out my project, we can be assured that it will work properly. And so what we can do here is type in the word pip freeze, and I can actually pipe that into less and just find the different packages here and just put in the version numbers that I want to keep. So we can see the Pytest Cov here, I think was 1, and Pytest, we can put those two right here. Just put these version numbers. That looks good. We can also go to Wikipedia, pin that library to be right here. That looks good. We can also go to pylint like this. We can go to the Python black tool as well. And then we can go to the Python fire tool and put that in. There we go. So Wikipedia, Pytest, Pytest Cov, pylint, black, fire. We've got exactly the version number. That looks good. And then if I just type in make install again, I can just double check, because this will again read that requirements file and just make sure that everything looks good. It is. There we go. We have everything working. So I can also check in the pinned version now. So I can type in get status, and we've got the pinned version. So let's go ahead and do that. We'll say get add star, change the Makefile, change the requirements file, and we'll say pinning installed versions. So we have a note here, and there we go. So that in itself is a huge win, actually. Even forget all the other steps of the Makefile, which are important, like formatting code, linting, testing, deploying, that if you're able to automatically verify that the versions of your software will install every time you run, that's a huge win for you in building out continuous integration. So this would be a good step for us to move into next continuous integration. So what I can do is I can actually go to back to my GitHub repo here, and we see this repo, and I'm going to select this icon, right, actions, and so I can even select this, and notice what it brings up is it says getting started with GitHub Actions. This allows you to build, test, and deploy your code, make code reviews, branch management, and issue triaging, right? You can see all these different kinds of cool things you can do, build projects with Make, build and test a project using Make. You can do a deployment as well on all these different kinds of platforms. Like, for example, deploy to ECS would be kind of a fun one that you could play around with. If I click on that button, right, it goes through and it tells you all the different steps that you would need to do in order to do a deployment. So pretty easy actually to set this up if you just follow the steps that they tell you inside of here. This would be a complex workflow, but in our case, I'm just going to do a simple one. So I'll even though we open that up, I'm going to go through here and delete this. And I'm going to paste in a very simple one, and we'll call this DevOps. We'll just say DevOps like that. And what do I need to paste inside of here? Well, I've already got an example here, and I can just grab it, GitHub Actions, Pytest, and let's go ahead and put this in. Here we go. We've got this thing. Pytest here, and I can just put those same steps essentially inside of here. So we just have to decide inside of here what are the things that we care about in our build process, and we can say, well, where does it run on? Ubuntu latest. We can also set up what version of Python we care about. So I would go back to my Python environment here and just double check what version of Python we're using. Let's make it match. So Python, okay, 3.8, that looks good. We can keep Python 3.8 inside. That looks good. Okay, let's go ahead and keep that. And then we look at the steps, install dependencies. That's the step that I want to start with. And then these other steps are linting, testing, formatting. For now, I'm going to just comment those out because we're not ready for those. And I'll just do the installation. So if I say start commit, this will check in this file, and I could put a note here that says start continuous integration. This will trigger the continuous integration, and we can watch that by selecting actions here, and it will do the first part of continuous integration, which is automatically install my software. So this is now making everything better, right? We're starting the process of improvement, because every time I make a change to my repository, it'll put this inside and essentially make it better, right? By pushing this change inside. Okay, this looks good. We're building out our project here. We can look perfect. Set up Python, install, lint with Python, test with Pytest, format the code, complete the job. This is good here. And now if I go ahead and I look at this this menu right here, if I click on this, we can say create status badge. I can copy this status badge, and I can actually put this inside of the README file as well. This is always a good idea so that other people or myself know that that this actual project is building correctly. So I could just paste that right in, and it's a neat little trick here. So we basically got the ability here, and once it's running, it'll eventually wake this thing up. But really, we have the beginning steps of continuous integration. So what's the next thing we do? We can just follow the Makefile. So this is really a pretty good order to follow. So the next step would be the formatting of the code. And this is a great idea to have an auto formatter, because before you check in your code, why not just clean it up so that in case you did a formatting error, you can clean it up before it gets polluted into the repository. So in order to do that, we would need to have some logic, essentially. So we have nothing inside of our code, and we have nothing inside the logic. So let's build out a logic function first. So we can copy the stuff that we built earlier. So I can say import Wikipedia, and we can build out a function. I might even just take that code. Let's just be efficient, and let's grab this particular function, and let's just throw this inside. There we go. Def wiki name war goddess. So it's got a default value. It returns back this. And what I can do as well is I can type in make format. Let's double check here. Okay, we don't have the format step. So let's go ahead and add that format. So we can say, I believe just black is the name of the tool. And we can do asterisk.py. And it should, I believe, look in there. And we can also tell it to look inside of the library. And we can say asterisk.py. So basically format these two locations. And now I just type in make format. There we go. It said one file formatted, 2 files left unchanged. So if we go back to logic, it slightly tweaked it. It makes it a little bit cleaner here, which is nice. And we're missing, no, I think we've got this. Unable to import this. I believe that this tool that is built into the editor just isn't aware of our virtual environments here, which is fine. We don't really care about that right now, but we were able to actually format our code, which is nice. And now I can go to the main file, and then maybe I just import it just to start off with, and I can just say print, or I can say from my lib imports logic. That would be a pretty common step here. And then I would say to print this out. So we'll say print, and we'll put in the logic and just call it as a function. And now I can also do format again, make sure everything looks formatted, and then I can go ahead and say Python main and it says, module print logic, module object not callable, because what I need to do is say, I see, I need to import wiki. I need to import wiki here. So I say from mylib.logic import wiki. There we go. We got that working. Python main wiki, not logic. Wiki. Great. Clear that out. There we go. We have our script running here, and now I can actually check in the format step. So we got another step out of the way. So get status, get add asterisk, adding format step. Now, because I changed things behind the scene, I'm gonna have to pull the code remotely because I made changes inside of GitHub itself. So I'll need to do a git pull right here. There we go. And it's telling me to run this command. Sure, let's go ahead and do that. And now I do a git pull again, and it's gonna give me a merge message. We'll go ahead and do that. And now that I've got that set up, I can do a git push. I'm gonna say git push. Perfect. And now when I go to this repo, it's going to trigger another build. And if I go to this icon here, it should go right into the build process, and I can just watch it. So this is, again, the process of making things better. Every time I make a change, things get better. In theory, right, you're either getting better, you're staying the same, or you're getting worse. Almost always you're getting worse if you don't have continuous integration. If you do have continuous integration, it's possible that you're making things better. And what we're doing here now is we're installing the software and we're formatting it. I guess we could even change the structure here so that the order matches our Makefile, like install, format, lint, test, deploy, if we wanted to. But it's really not necessary. So the next step would be the lint step, which would be the PyLint step. And I can look at another project here where I have a lint step and just look at how I did it before. So this is how I typically would do lint, and I can just grab this and change it a little bit. So if I go through here, I can add this lint step. And what I'll point out here is that I typically will disable warnings like the recommended and the configuration, because this will fail the build, and I don't want those warnings anyway. So I just say -s disable equals R, C, and then from here I would just need to point out what code I want it to lint. So we could say the same thing. We could say basically every Python file, and in fact I could just grab the same thing. You could just say lint these pieces of code here, and then also lint the library code as well. And then I can just test this out by saying make lint. There we go. So now we're able to check the linting. Now, linting is something that's worth pointing out. Why would you care about this? Well, sometimes you make a bug that is not even logic bug. It's just essentially an error that could crop up later, maybe 3 years from now. And so a good example would be, let's say inside of here, what I do is I say, results is equal to wiki, and then I say results is equal to result. Like it in theory, this would still work. And in fact, I could even print the results, right? So in theory, this code is actually syntactically correct, and it won't blow up. So if I run Python main, right, it still works. It's just bad code, because this could potentially cause problems in the future. And so if I type in make lint, it'll actually complain. It says you're assigning the same variable result to itself. This is a warning that you're going to get yourself in trouble at some point. So why don't you stop that? Like, there's no reason to do this. This solves no problem. And so in order to get rid of it, I would actually, delete it. Now let's go ahead and push this change so that we can double check the process of building. So I'm going to go back into my GitHub file here, and I'm going to change this process, and I'm going to say make lint, or let's leave that, and let's just add a make lint step. There we go, make lint, and we have the make lint. Actually, no, I can. Why don't I just uncomment that out? There we go, make lint. So if we've got that make lint step uncommented out. So I can now do get status, add in the GitHub build process step, and then do star and say commit adding the lint step. So this will actually break the build. And this is where the continuous integration step is so critical, is if I go back to my project now and I click on actions, it's adding the lint step, and we can watch what happens when you check in a step that will fail, will be alerted about that failure. So this is a really great warning system, or early warning system, that they'll tell us, hey, look at this, you've got a problem here in your code. You need to fix this, right? This is bad. In fact, we can even put this as a little screenshot to just show, like, the whole point of what we're doing is to prevent these kinds of problems. So we can say a note here that says, populate Makefile, and then set up continuous integration, and i.e. check code for issues like lint errors, and then I can just put that note right inside of here and paste that into this project, which will be pretty nice. I can just paste this inside. There we go. And we can just say lint failure, just like this. And if we commit this change, there we go. We can see that this lint step is failing. So how do we fix this? Well, what we can do is we can obviously get rid of it. So maybe for now, I'll just delete this out so that it'll work. So let's test it locally, make lint, it works. So let's go ahead and say get status. We see only one file needs to be changed, so I can say get add star, and I can say get commit here, adding change to lint, and then I also can push. Now, or I need to do a pull first because I added that document. So let's go ahead and do that, and then we can do a get push. Now, one thing that I also should tweak a little bit is notice that this thing is saying the import, basically there's some kind of an issue. Well, if I go to this down here, this workspace, that's always something to double check, make sure, and it does look like it's actually choosing the right Python interpreter here, which is the .v here. And in fact, you could always change it though. You could go like this, and you could say tilde.venv bin Python right here, and you could always manually put it in as well. But if you are having issues with a Python virtual environment, in this case this is the right one, but that you can always double check here that it's actually checking it, putting it into the same, into the right location. But we're in good shape here because we are able to get the installation step done, the formatting step done, and the linting step done. So what would be a next step for us would be to go ahead and set up testing and to set up deploying next. And this is when we could get into building containers as well. And potentially we could even add a step here that would be a build step. So why don't we even do that? Why don't we add a step that says build? And we can do here and say like build container. And this can be pretty useful because the building the container step is often associated with modern projects. There's tons of different web services that you can build out by using the Docker container. So let's go ahead and check that in. Say git status, git add this, and go ahead and commit this change. So adding build step for container. Actually, build container. Perfect. Build step for container. There we go. And we'll stay back with this project and go on to the next step. Okay, so I've got the installation step going, formatting, linting. Let's go ahead and build out a test now for our project. And probably a good place to start would be to test the logic of our code. And that should cover a lot of the vulnerable areas of our project. So let's go ahead and say here, touch, and we'll say test, and we'll say test underscore logic, which would be a good way to signify that this test would be testing the library code. And I could go ahead and go to this file and say basically the same thing that this script is doing here. I'm going to just grab this line of code and just paste it in. Here we go. From my lib.logic, import wiki, and now I can build out my test, and I can say def test wiki, and we would just need to assert something inside. And so in this particular scenario, this would be more of I guess an integration test, because we're calling something that calls out to the world, and we know that if I run this, right, if I go through here and I say Python test or Python main, that it will execute this code. This does get a little bit tricky to test because Wikipedia isn't guaranteed to be non-deterministic, and so that does potentially present some issues for us to actually test. Just, I suppose, for fun here, what we could do is we could just test it in a more crude way and just not worry about that, and say assert that the word God is in the output, like this. And if we go through here and we say make test, it's not wired up yet, so we need to actually wire this up. So I'm going to look at a former test that I have set up, which would be this, and paste this inside of here. So we'll go to the Makefile, and I'll type in python-m pytest, and then put in test logic like that. So the reason I do this here is so that I can actually basically test that library code, but I also could pass in this flag as well, which is cov equals the library, right? So this would be my lib, and so this should tell me as well how much test coverage is inside. And in this case, it says directory was not found. And cov equals mylib. I need to look at the Pytest cov documentation, Pytest cov to double check what it's asking for. And we can look here and say plugin coverage. Oh, I think you do dash, here we go, dash cov equals. So I didn't do dash cov. Okay, so let's do that. Let's do dash cov like that. There we go. That should fix it. And if I save this, I can say make test. And it's going to not only make sure that our code is working, but it's going to show that I have 100% test coverage for my library, which is nice. And if we want to verify that it's not working, we'll say assert, fruit, or something weird that won't work, and let's just double check that fails. There we go. Right, so we see that it fails if I put in the wrong phrase. It says a fruit is not inside of the output of this. So I can just back that out, run it again, and we see that we've got test coverage. So we can now go on to our GitHub file here, and we can uncomment out the next step, right? Which is basically make the test. And so let's go ahead and do git status and check in these changes so that our build system can also show the test coverage. So we'll say git add.github, git add star, and commit this, adding changes to allow testing. And we're really doing quite well in terms of being able to build out a rich project here. We've got our testing working now next, and we can actually just take a look at this. Okay, this looks good. And let's go ahead and check out this project, installing dependencies. That worked. Linting, that worked. Formatting. We have all these things running here. Let's see, did I enable formatting? I don't think I did enable that yet. I've only enabled testing, right? So we can see make test. So let's go ahead and double check inside of our file here. We don't have formatting. Let's go ahead and enable that as well. So let's do the final step here of formatting. So we'll say git add GitHub, and I'll put a note here that says adding changes to allow formatting. So this will just check to make sure that in our build process we can see whether there are potential changes I would need to make in the future. So let's say somebody on my team that I'm working with 10 of the people, they check in some changes. The formatter would basically say, hey, look, we need to format. So you might know next time you check out the project, oh, let's actually format our code to fix these formatting changes that somebody, maybe they checked in a huge library and it's got the formatting in a way that needs to be fixed. This thing could actually detect that, so that next time you work on it, you could actually run the formatter locally and then push those changes. So the formatting in the build can also be very useful. And here we go. Here we have right here the formatting steps. So we have testing step, we have install, lint, test, format. We have all kinds of great stuff working. So now we're ready to basically build out a microservice. I think that would be the next logical step here. So I can work inside of this environment and build out a microservice. I guess maybe the first thing though, before we even do that, before we build out the microservice, would be to test it out, potentially how I would want to interact with this by using a command line tool first. So I'm gonna just make a command line tool here called, we could either use fire or we could use click. I'm gonna go ahead and use fire. We'll say CLI fire, and inside of here this will actually give us the ability to build a chameleon tool. So I'll need to put inside of here, oh, we already got Fire installed, perfect. And I would just say import Fire first, and then we would say the same thing I did in my test. I could just grab this like that, and we go to the Fire tool from my lib.logic, import wiki, and then I could add a if under statement here. So I would say if under name is equal to main, and this just tells the Python interpreter only run this code if it's run as a script. And so we could just go down here and we could say fire.fire like this and just put in wiki just like that. And this should be all we need in order to run this as a chameleon tool. So pretty powerful library here. And if I do this, this is a shebang line, which tells it to run as a script. And so if once I set up this shebang line, I can say chmod plus x CLI fire, and then I can just pass it in like this. And if I do -- help, it shows us a help menu automatically. And look, it's able to even intercept and dig into that function and tell us everything that's going on. So this is kind of an amazing library actually, because it uses metaprogramming to like fetch inside of the function and find all this stuff up. And look, it even looks inside the docstring here that we had set up, and it's able to even grab that out and use that as the help menu. So a neat little tool that's available from Google here. And in fact, I guess I could even put this as into our documentation that we're building out. Let's go ahead and do that. Let's do this. Let's go into the README. So we've set up continuous integration. Maybe step 5 would be to build a chameleon tool, build a CLI using Python Fire library, and you would just do something like this. And the reason for this would be to, like test the logic, right? So we want to kind of interact with this thing to see how it will behave before we go maybe to a microservice. So fortunately, very easy though. Once we've got this set up, I can do the help menu and I can just pass in, just run it, and there we go, it runs. And then if I want to pass in something more, if I say length, why don't we do 10 sentences? There we go. We see that it's got a bunch of sentences here. And then I could even pipe that into another command, or even pipe it out to a file or whatever, right? And use this as a chameleon tool. So it's amazing actually how powerful of a tool this is with just a little bit of library code using this Python Fire library. So let's go ahead and format this. Let's format everything. This should clean this up a little bit. All these pieces of code. The other thing that we can do is we can actually verify that the lint step works for this as well. And so if we go to the Makefile here and we look at the pylint step, here is actually a command, and notice that what this -- disable does is it disables the recommended warnings and the configuration warnings, which are typically too verbose for a build process. So that's why I disable these. And we can see that it's going to cover all Python files, including this new one that we've created. So I can say make lints, double check that everything looks good. Yeah, so we have now a chameleon tool that is pretty useful. And I think I could even do like, let's test out a different option. Let's test in name. Let's say LeBron James. Does that work? Let's see if we can put a basketball player in there. see if it's able to grab its Wikipedia page. Nope, didn't work. It may be underscore for LeBron James. Well, it didn't work. Let's try LeBron. Does that work? Well, we may need to tweak this thing a little bit. How about Lebanon? Let's try Lebanon. Let's try something that will make it easier. Well, that one didn't work. How about NBA? Does that work? No. Some of the names are disambiguated or are easily confused and not disambiguated, so they're trickier. But I guess I could look at Wikipedia real quick and look at LeBron James or somebody. LeBron James, and yeah, I thought that this was his Wikipedia page. I'm not sure why that's not working. Let's try one more time to see if that works. LeBron James, yeah. For some reason that's not working. We don't need to obsess over it, but we have at least something that's working, which is where we have the default value that gives us back that result. So let's go ahead and push this change as well, and we'll go ahead and say git add star, git commit, adding the command line tool. So the reason I like to build these command line tools out here is that it really is a good way to just kind of test the edge cases. So like in that case, we saw that there's something going on here with the logic of our code. It's like, maybe we need to figure out, a better way to interact with this library or protect the user from errors, etc. And it's a good way to play around with it, because if I was going to write a bunch of tests, for example, that's one way I could solve it, or I would have to actually write tons and tons of scripts. So command line tool allows us to really quickly interact with things. So now that I've got that working, I could convert this into a better tool here that is able to maybe be a little bit better at solving problems. And I guess one of the things I could do is I could install IPython locally to play around with this. This is how I kind of think about things when I'm solving a problem. And so I can do a pip install of IPython, and this will allow me to interact in an interactive terminal here. And if I type in IPython, what I can do is I can import this library now. So I can say from logic import wiki, and from my lib.logic, import wiki. And once I've got that, now I can play around with this function, right? And I can kind of test things out here. So yeah, I guess that's one thing that would be interesting to figure out, is this Wikipedia library in Python. Can we look things up a little bit? Let's look at Python Wikipedia, and let's see if there's a better way to interact with this library to fix this code a little bit. So we can see pip install Wikipedia. The build's failing. That's not a good sign, but we can see, okay, so you can search for names as well. This might be one of the ways we could fix this tool, is that we could basically build out actually a search, and then that way the user could always pick the right page. And so let's try this. Let's build out a little more logic, and we'll call this def search wiki, like that. And then we'll do the same thing. We'll just say name will be some value that we search, and we'll say, search Wikipedia for names. And this will go ahead and intercept this. And I can say results is equal to wikipedia.search, and we'll put in name right here. And then we can say return results like that. So this is a little bit better for us, because this might be able to prevent that issue with not finding names in Wikipedia. So let's go ahead and do that. Let's open up IPython again, and now I can play around with this library. So I can just use the up arrow. That's one of the nice things about using the command line version inside of a software development environment, is I can play around with this and say, oh, okay, here we go. But I also can import that other library, which is search wiki. And all those things I was covering earlier, we can now use again, right? Right? So I can see what's loaded into memory. So let's go ahead and try out the search wiki here. And let's do what they told me, which is Barack. Let's see if you can find Barack here. There we go. Barack Obama. In fact, I misspelled Barack Obama. There we go. Search for Barack Obama. So I guess I could even then get more of a feedback loop. Okay, Barack Obama, perfect. Now, what if I put in Barack Obama into the wiki? So let's go ahead and do that. We'll say wiki, and we'll do this. Barack Obama. Whoops. For some reason it hopped screens here. So wiki Barack Obama. There we go. And close this. There we go. So pretty neat that I was able to actually figure that out, and gives us a nice little feedback loop. So this is definitely an improvement of our code. One issue though is we'll need to look at the Python Fire documentation to see if there's a way to combine two functions together, which I'm not sure. So this is what we're doing, which is really neat. But what if I want to do more things together? Python Fire. How would I actually turn component into Fire CLI? Turns the current module into a Fire. Oh, wow. So you can actually turn the entire module into a Fire CLI. Wow. Okay, let's do it. That's pretty cool. I didn't know you could do that. So I'm going to go back to my CLI here, and instead of just doing this, I'm going to, this is where things would get interesting, is I think what I would need to do is basically, let's try this out. Let's see if I put in logic like this might be able to take the whole module and make it into a CLI. Let's see if it can do it from my lib import logic. And let's try it out. So if I exit this, what happens if I say CLI fire -- help? Does it even work? And it does appear to basically take that whole thing and convert it into command line tools. Man, this is amazing. This is an amazing tool. Group is one of the following, either Wikipedia or search Wikipedia. So now we have a more sophisticated command line tool. Then now a user can have basically more of an interactive workflow. So we can tell the user, okay, let's try the search. In fact, I guess I should have followed my own help menu here. What's it telling me to do? It says search wiki. So that name is not great, but it's not horrible either. Let's try it out. So we'll say search wiki, and we'll say Barack. There we go. And it tells us all the different things that we can now use to get the actual Wikipedia page. So we're basically building a terminal-based interface for Wikipedia, which is actually pretty neat. And now I would just go through here and I would say wiki, and I could take the results of this, and this should give us Barack Obama's results. There we go. Pretty neat that we were able to do that quickly. And then if I want to do get status, what are we missing here? The CLI was changed, the library was changed. So say get status, get add here, get commit, adding a new CLI functionality. And we can go ahead and push those changes. So now that we know that we can potentially build a nice little interface there, I think we're ready for our web service. And so one of the easier ones, the two ones I like are either Python Flask or Python Fire or Python FastAPI. Let's go ahead and start with FastAPI here. And so inside of the main, I'll just need to tweak this a little bit. And I can find maybe another project. Let's go ahead and go to my GitHub here and look for a FastAPI scaffold where I can just take some of this and put it in here. So here's a project I did earlier where I have some code. I'll just grab some of this and put this inside, and we'll just tweak this a little bit here. So we'll do this. So I can still take my import, put this down at the bottom. Typically the order you want to do imports in Python would be third-party libraries first, then your own code. So in this case, we're going to import FastAPI. Now I need to install FastAPI. So I'm going to have to add this to my code, and we'll say FastAPI and also UVcorn. UVcorn I think is the one. And let's go ahead and do make install. Make sure these both work. Perfect. And now if I do a pip freeze, we see that I've got UVcorn right here. And we also have FastAPI, should be right here. And let's paste this inside. There we go. So we got FastAPI, UVcorn, and I can just double check that these work again by doing make install. So we're doing well at keeping a nice solid structure here that's reproducible. And I can also say make status, and we see that, or I'm sorry, get status, and it shows us that we've changed a couple files. But let's get this thing built out. In order to build out the microservice, we would have, I would think, always a good idea to put some kind of a message at the root here. In this case, the message we could put would be, Wikipedia API, something like this. And we could say like call search or wiki, something like that. So we can build two API endpoints that would map the same thing we did in our function. So the first thing we can do is we can do the search, which would let someone basically put in a search phrase. So this one will be pretty simple. In fact, we could accept a JSON payload, but if we want to be lazy here, we can actually not accept a payload. We can just put in like a value, and they could just put it inside of the URL, and we would just change this to be stir, like a string, and do this to be value, and then change this to be search, like that. And in this case, we would potentially say import wiki and our logic, search wiki, yeah. Our logic would be wiki and search wiki, like this. So we're importing those two things, and I guess we could say import search like that, and we could say from mylib.logic import wiki as wiki logic or something like that. So basically I just keep it a different name here, and I don't know why that's giving me errors, but who cares. Wiki logic, and first one I'll build is the take this out, we don't need this, and we can say, you know, page to search, you know, page to search in Wikipedia, and we can say the results would be this, and we could do basically the search. Wait, what did I import here? Search wiki, yeah. So we'd say search wiki, and we would do the value. Right, so basically it'll make that API call, and then we would say results will be result, or result is equal to result. There we go, that looks good. So this should, in theory, give us a search menu, so or a search results. Let's see if this works though. So what I'll do is I'll just type in Python main, and to run this thing. Let's go ahead and do that. Python main, like that. Does it work? So far so good. And I could even do it in a web browser if I wanted to. That's one of the nice things about this environment. I guess we can try it out. There we go. So look, it says message, so basically search Wikipedia API, so call that. Okay, well, let's try it. Let's do search, and let's do Barak. There we go. So we actually have a working web service here that returns back the results from Wikipedia. So it's amazing actually how quickly you can build web services if you use this kind of a structure and try, you know, to structure your project like this. So we've got that working. That's great. Now we just need to build a second endpoint that will allow us to then put in the actual page to get the results out. So let's go ahead and do that next, and we can say here, we can, just to be lazy, I'm just gonna copy that and just tweak it. So we'll say, we'll call this one wiki, and we'll say wiki, and this will be the name that we're going to put into the Wikipedia query, and then we'll put in same thing, value inside of here, or let's put name. Let's keep it different. Let's say name here, and we'll say retrieve Wikipedia page, retrieve Wikipedia page, and this one will say, I think I put up here wiki logic. We'll call this wiki logic. So we'll pass this in to this, and we'll call this name, and then we'll say yeah, results good. We can keep that the same. Okay. Now if I do a make lint, that's a good step to just double check. Okay, good. We don't have anything obvious going wrong, and I can say Python main. It'll go again here, and it will give us the results. Great. And then I could actually do my results here. Now, one thing to point out that's nice about FastAPI is I can query it like this, but I also can query it by using docs. And if you are going to build out maybe a post request where it accepts a JSON payload, this really is handy. But if we go here, all I need to do is I can try this out. I can just put in, search, and again, we can do this. We can say Barack, find Barack Obama. There we go. Results here. Then I can just take this value, and then I can find the other payload. In this case, we'll go to this, go to Wiki, try this one out, and then paste this inside. Barack Obama, execute, and there we go. We're able to actually get back this result. So we actually have a full functioning search interface for Wikipedia, as well as a website retrieval. So I could do the same thing if I go to the other URL, like just the non-documentation. So if I go through here and I say wiki, we can type in Barack Obama, and there we go. Barack Obama is able to be queried as a result. Now, I don't know what happens if I put an underscore here. What does it do? Does it also find it? Yeah, so you can also put an underscore, which is a little cleaner when there's a space, and that appears to work as well. So we've really made a lot of progress in terms of building this web microservice. I guess what we could do is potentially even add one more method, which would be something that could do some kind of natural language processing on the results, and I don't know, like maybe we could tokenize or count the words or something like that are in common. And I think one of the ones that I've seen a lot of people use that's open source, I guess we could just do a Google real quick, is like, best open source Python NLP libraries. And let's just look what are some of the best ones. What do we got here? We have Natural Language Toolkit, GenSim, Spacey. These are all, I've used some of these before. Let's try potentially, I think there's GenSim, text blob. I think I've used this one. This is a really easy one. Let's use text blob here and see if we can do something with it. So from text blob, you just give it a piece of text, and then you can just find phrases out of it. So that could be kind of fun, and you could even do like sentiment analysis and things like that. So that looks pretty interesting, actually. So let's go ahead and install text blob. And let's add this to our project. So I'll go to the requirements file, and let's add text blob, and we can say make install. And I will also grab the pip freeze here, pip freeze, and text blob. Let's put this inside. There we go. So we've got that working. Now I just need to tweak this a little bit by adding a third route, and instead of here, we could, I guess what we could do is we could say like phrase. That would be a good one, and we would put in the name, and we would put this phrase. And probably would be a good idea, though, to retrieve Wikipedia page and return phrases. Something like that. Now we should probably we should probably put this in our logic, though. So we should probably do this. Whoops. We should say, look at the test blob text blob library and say this, and let's put this back into our logic. So from text blob, import text blob, and then let's make another function that says def phrases, and this will just take a name, and we can use our other piece of code here, and we can just say returns phrases from Wikipedia, and then we can use our other function here, so we can say the page is equal to wiki, and we just pass in the name, and then we would say the phrases is equal to, and we just copy what they say, what they do here. So we say this blob, put that in here. Oh, we'll do blob first, blob, and then we'll do phrases and put that inside of here. So do that. So we have page is equal to wiki, blob is equal to the page, and then we would just return back the phrases is that. I mean, I guess we could be lazy and just not even put that line in, just do this, just say return blob noun dot phrases. Okay, now because we have the Python Fire library, it's going to be pretty easy that in theory we could just run Python Fire and call it phrase like that, and let's see what it does. Oh, we need to download the necessary corpora, which is a little bit of a pain. So we'll go ahead and do that. And now we can do this. And there we go. We were able to generate the phrases as a result of this. So that is pretty neat, actually. We were able to test that out. So let's go back to our main function here, and we just basically call this library code. So we would just go here and we say from mylib.logic import phrase, and we just pass that in. So we just say def. We'll call this a phrase as phrases or wiki phrases or something like this. Wiki phrases. So let's just change the name so that they don't conflict, and we can say wiki phrases. So that's, I think, all I need to do. And now I can go through here and run the main. It starts it up, and in theory I can just pass in phrases and then put in Barack Obama, and it didn't do something. What does it say? Oh, it didn't. Well, let's search it, which is here. Let's search for Barack Obama. Maybe I'm doing something wrong. There we go, Barack Obama. Let's try that. Let's just try to paste in the phrase that way. Phrases Barack Obama. Still not finding it. What am I doing wrong here? Wiki phrases name search. It was able to find that, but somehow this is wiki name phrase name. Not sure why this one wiki phrases from wiki phrases. This should be this should work. What I could do is just add a print statement inside of here. And we could say print, this is a good way to debug things because it's in foreground mode. I can say print the name like that. And then, and I could say passed in name and put an F string here. And then try this out. Passed in name. And let's see what happens now if I do this. And then we could do another one below this, which is prints the results, and just see what the result is here. There we go. Let's go ahead and try this. Let's stop it, restart it. Go back to the web browser. Not found, but what does it give us here? Does it not print this out? It should be printing this to standard out. I may need to do, there must be like a debug mode or something where it's able to print these out. It is a little bit weird that it's not printing out this to standard out. And so I'm going to go ahead and just keep working. We're making lots of great progress, and I'm going to move on now to, let's just write a test for this. Since I got burned, let's go ahead and fix our burning, right? And so I can actually just go to the documentation for FastAPI and just copy their example of how to make a test. Okay, this looks good. And in this, I think this should be pretty easy to figure out. So you can see here I was able to fix that endpoint because of it was just a misspelling. So let's go ahead and make a test here. So I'm going to make another file called test main. So we'll say test main.py. And then inside of this, we can build this out. Here we go, from FastAPI, import FastAPI, and from FastAPI to test client, import test client. We got these things working. Now the app though, what I'll need to do is import that from the main file. So I'll say from main import app, because I already defined my app earlier. I don't need to, and then I can make a test client. And then from here, we can basically look at the response here and look at the main file and first test this. Let's just make sure that Wikipedia is, well, let's just put this is what should show up in our test here. So test main message, I believe it's that. So if I say, and then if I change my Makefile here to include that, which would be, well, we could just change this to test asterisk, and that will test all of the tests that appear. And let's go through here, and we'll just say make test. Here we go. Aha, we have an assertion failure because, oh, see message. So I need to match, it was actually message here. So that's a good sign that our test is working. And now if I say make test, we see that in fact I've got this working. Now I can also add the logic. See how I have the coverage here? Why don't we also add a step for coverage for the web app equals main, and then do another test run, and we should see that we have 70% test coverage, right? So there's still a piece of the code, right, which is the route I had a problem with that needs to have a test. So let's go through here and let's just build one more and do this. And we'll say def test, and we'll say read the route here, which would be this phrase. Let's go ahead and write our test here for this. I guess we could test all the routes, but we'll say phrase 200, and we would want to do something like phrase and put in Barack Obama, like that. And then I guess we could just see what the result was when we run that. Let's do that. So if we do this, we open up in a web browser and we type in phrase Barack Obama. It should go find it. There we go. It worked. So it's gonna come back with a result like that. We could essentially, I don't know, we could do something like this. We could look for whether that appears inside. We could say the result would be that result would be in there. So we would do this, results, and I guess I could paste out the whole thing, which we could do this thing. Let's paste this inside like that. So in theory, that might work. I'm gonna do a format to clean this up a little bit. Make format. So again, formatting is awesome. That's why I have that formatting tool. And now if I do make test, does our test work? Aha, there we go. We're able to test this out. So we've gotten a lot closer here to having a pretty cool microservice, professional type system set up. So we got that working. Let's check all this in, and we'll commit this, adding FastAPI. Okay, we've got this thing cooking. It's pushed in. So what's great about having all this stuff set up is that now we're ready for containerization of our application. That's really the next step. And so what I can do is build out a container that will have everything that I need in my application. And so I can just grab a container that I have at one point had working, and let's go ahead and maybe just tweak it a little bit. This has got some stuff from AWS, so I'll tweak this a little bit. So I want to actually use Python, the Python Slim library, and let's find Python Slim 3.8. Let's kind of match this. Let's match the same version of Python, and I think we have Slim Buster. We want to do 3.8. In fact, we could just say what version of Python. This is Python 3.8.12. We may even be able to get the same version, 3.8.13, 3.8. Well, we'll just pick this one, 3.8.13 Slim Buster. That's probably the one we want. And that looks good. So we can grab that. We can say Python 3.8 Slim Buster. There we go. This one. And we can just paste that in from Python. Let's see. I think it's this. I think you do Python, or is it all uppercase Python? I forget. We can just Google this and find out who's put that in a Docker file. Let's see. where's example? Someone has to have put this somewhere. Is it that? Is that how we do the from Python? Example. I think I have one in my GitHub. I can just take a look at it real quick. And I think it's under fast or doc or cloud. I think I was looking at this before Cloud Run Flask. I have an example, I think. Yeah, here. From Python. Well, we could do, so it is lowercase. Okay, we'll just do lowercase. So it's from lowercase. That's all I needed to know. Once, and this is gonna get that container image. Slimbuster is basically just like a smaller version, so it doesn't make a huge image. And I make a directory called app. I copy the FastAPI application inside of there. I set this as the working directory. I install my packages. I expose that port here, and then I go ahead and I run this. So let's go ahead and do this, and let's go ahead and say, in this case, let's do a build step. And there's a couple different ways to do a build, and I can show you how I've done this previously, which is that in this FastAPI process here, what I do is I just say docker build dot, and this will actually get the image for us. Now you could also do a -t to give it some kind of a name, and that's also something that could work as well. And in fact, I think I have a container or a project here where I have an example of that workflow, which is here, docker. Like, so basically, if you do a docker build process like this might be a little bit easier to look at. So what I can do is in my Makefile under the build, I can just put that command. I can say docker build -t deploy FastAPI. So let's try that. Let's just say make build like this. Docker build -t deploy. This will go through here and make this change. Okay, so now that I've got this built, how do I actually find the container? I would just type in docker image ls, and there we go. We see that we have this image ID set up here. The repository would be deploy, FastAPI. So I've got this thing working, and if I want to run it, I guess I could even add a run step as well here to get this. I could say run. Run docker. I would just do these steps that I had earlier here, which would look something like this. So let's go ahead and put this inside and do docker run, and then put in the image ID that I care about. And this will run this on this port, do it under 8080, and we'll just say docker run, or sorry, make run, which will then run that docker command. And look, it looks exactly how we had it before, except for it's all containerized in this one application. Now, there is one gotcha that I think we'll be able to find out, which is that some of this will work, but I think one thing won't work. So if I do phrase Barack Obama, I believe this will blow up. Yep, it'll blow up because we didn't load that library. If you remember this one right here, we need to put this step inside of our Docker build process, and this is the issue. It's telling us exactly that's the issue, which is exactly what I thought would happen. So we need to do two commands. We need to do one more command, which is this, python-m text blob download corpa. And so let's go ahead and build this again. So say make build like that. And let's rerun this. And let's just see if this will fix this. So it installs the software. Looking good. Now it's going to run this. It's rebuilding it. Now I'm going to go ahead and I'm going to find Docker image ls. We can see the one that was created just 9 seconds ago. This will be our image ID. So let's go ahead and run this. Oh, Docker. Well, actually, I don't. For the run command here, the run command will be a little bit different because this ID will obviously be different. So maybe what I should do instead is just put this as like a commented out step, right? So if I do this, I say make run, it'll just show me the command that I would need to run, right? And so then I can always copy it. I could do something like this, so that I just have an example of how I would run it. In this case, I think this is actually the idea I need. So we'll go through here and we'll say Docker run. And now if I go through and we go back to phrases Barack Obama, this should work. Aha, it does work. So this really highlights the value of containerization because it makes a new isolated environment. So we're in great shape here. I can actually even test out the build process as well inside of our code here. And so let's actually say make format, and we can even say make build just so I can like test out that the container is built properly. So we say, and I guess I could even push the container even inside of GitHub has their own container registry. That's a little bit of work. I'm not going to do that, but I'll just say build container. And we can go through here and we say run, add this, and say make build. And now I can say get status. And let's just see if all this stuff works. If it does, we're ready to do the deployment steps next. Adding build. Okay. All right, that looks good. If I go back to my project, which would be this project, which would be DevOps right here, we can double check that everything is working. Let's click on it. So it's linting our code. So in this example, lint is failing unused FastAPI import in the test. Oh, okay. Well, that's interesting. So that's let's go ahead and do the make test here. And then that looks good. I guess I didn't do lint locally. So it's catching something for us, which, aha, unused import from, unused FastAPI import from FastAPI. Ah, yeah, I don't need that. That's right. So under the test main, we don't need this. Good catch, right? So it's always better to just have clean code where we don't need any of this. So make format, that's good. Make test or make lint, that's good. Perfect. Okay, let's go ahead and check these changes in. Adding changes There we go. So now that I've got this thing, I can double check the build one more time, and we should be able to verify that all the steps are successful. Okay, this is looking good. We have installation. Next we'll go to the lint step. Great. Next we'll go to the Pytest, that works. Then we go to the formatting step, that works. No, the Pytest is failing now. So, oh, because this is a good thing it figured out here, which is our build process also needs to download the same library, right? Because the build system doesn't have access to that command. And so if I just go through the history here, I can just find the command that I did earlier, which is this Python text blob, and we can just add this, in fact, to the build step of the build server. We can just add a block under install. I guess we could just add this to, we could add this right here, which would be right after make install. You could just do this command. And let's try that out, see if that works. Add commit, or we need to add this the dot file. There you go. Commit this and push, git push. If we go back here, this should build this for us. So the build server really is powerful because it's easy to think that you've got everything set up in a reproducible way, and then the build server will expose that you don't. And that's why it's so great to have a build server, is it really it finds the weaknesses in the reproducibility of your project. Let's go ahead and test this out, make sure that it works. Okay, but we're waiting for runner to run this. There we go. So it's running. Aha. It's installing code here. Let's double check that it's going to do that last step, hopefully fine. Yep, it did that. It downloaded the corpus. And now we have the lint step, we have the test step. Test pass, formatting is passing, the building a container passes. We've tested pretty much everything possible in our code. Amazing. So we have a nice process here. So the final step then would be for us to deploy this. And so what I'm going to do, I mean, there's a couple different ways to do it. You couldn't deploy directly from GitHub Actions, which is totally fine. But I'm going to just deploy using the AWS tool, which is called Code Build, which is a little bit different. But here you go, everything passed, right? So let's go to a AWS utility by going to the console of AWS. I'm going to log in, and I'm going to pass in my auth code here real quick. And this will be pretty easy actually to build. We really don't need to do that much, in fact, to get this to work. All I need to do is go to something called ECR, Elastic Container Registry, right here. And we just need to be able to push something to this container registry. So I'm going to create one called, like wiki, and we'll go ahead and create this repo. And it's not too bad once you've done this. Oh, wiki or fast wiki, FastAPI wiki. FastAPI wiki, how about that? There we go. FastAPI wiki. I must have done this something like this earlier at some point. So we have FastAPI wiki here, which is this one, and you just have to view the push commands. So these are all the push commands. Now fortunately, it's actually pretty easy to get this full automation working. And so what we would need to do is put these steps into our deploy process. So I'm going to copy each of these, and I'm going to go back to our development environment here, and I'm going to put inside of our Makefile these deploy commands. So basically, first one would be that it's going to need to be able to authenticate to Docker. That's step one. Second is we will build out this tagged right here. We'll say building Docker file from scratch. You can skip it if it's already built. In this case, we do want to do that step like this, and then we want to tag the image, which is we go here and tag the image, and then the final step would be to push. So this won't work in this environment because of the fact that I don't have my AWS credentials. I could install it and get all that working, but because I don't have the AWS credentials, this won't work here. I can check in the code though, and I could actually create a build process for this inside of AWS. That's the easier way to do it. So in order to do that, I would go to code build right here, and I would create a new build project. And so if I go here and I say create build project, we could call this deploy wiki service, like that. And then I would go inside and say build Wikipedia service, and I can even do a build badge if I wanted to. And from here, all I need to do is tell it where the code lives. In this case, we'll pick GitHub, and it will be a repository inside of my account. There we go. Next up, what I'll do is I'll take this project, which is Python for DevOps April 2022, and go down here, rebuild it every time a code build is changed, which is what we want for continuous delivery. And then we select what kind of image. You can just select Amazon Linux 2, and then standard, the latest runtime. And then because we are going to build a Docker container, right? That's what we're doing. We're pushing this to Docker. We can push this, select this, and then also select an existing role. I have already set up a role in AWS that has admin privileges. And so here it is, an admin role, so that it can push. I mean, you could specifically tell it what privileges. In this case, I have one that has administrative privileges though. And now this is the only thing you really need to care about is use buildspec.yaml file or insert build commands. I can basically just essentially copy this thing and turn it into a buildspec.yaml file. In fact, I think I already have one in another repo. I'm just going to click use build spec, and I think it's in this repo. I have a build spec file, And look, it can be this simple. It can be something kind of like this. So, and the name is called buildspec.yml. So let's just make that file here, touch buildspec.yml. So this will tell Amazon to do something kind of similar to what I was doing with GitHub Actions. And if we scroll down to build spec, I can just change this. Instead of make all, I just say make deploy. Now I could do all those steps, right? Like install, all those as well. But so it just really depends what it is we want to do. I think it's not horrible though for us to do this: install, lint, test, deploy. Yeah, let's do that. Let's do a make all. So actually it's the exact same command, make all. And then I think that's it. We've got the Makefile set up here. These would be our commands. We have install, lint, test, deploy. Okay, let's do it. Let's say git status, and we'll say git add Makefile, git add build spec, commit this, adding changes to build spec, or adding changes to allow deploy to ECR. There we go. And now that I push those changes, I can say use build spec, and then I can just say create build project. So now that build spec is there, I should be able to just say start build, and this should go through and then basically push this into the ECR environment for us. So let's see if this will actually work out. And we go through here. And so far installation phase is working. So we're doing similar things that we're doing in GitHub Actions. We're just using a build system that comes with AWS. Okay, this looks good. This is looking good. Oh, well, we have the same problem, right? We didn't tell this build server to install that package. So it's going to have the same problem, which is exposing a hole in how we do things, but not a horrible hole. I mean, we can just do the history command here, and we just need to run that one command. Definitely makes things a little more complex, but not horrible. We can just say inside, we could do a command here that says post install or something like this. We can just do this. We can say, post install like that, and then do this Python install like that. And then inside this, we just say install and then do post install, right? There, and that would download the corpus for us. I think that would work. Post install, yep, that looks like that would work. So now we're doing the same make all still, git status. Let's go ahead and add this, adding Makefile. Okay, let's push this change here to code build. Let's try it again. So this one failed, so it didn't push it. Let's see what the new change though will do, because every time I push a change, it'll re-trigger the build. In fact, it did, which is pretty nice. And so this is in fact exactly how continuous delivery would work. Is you would go through and do the installation, do the linting, making sure everything works. If it all works, build the container. Then once you build the container, push the container And so we can now see the new process, which I believe will fix that issue.